If you think LLMs are hallucinating monsters that cost a fortune to run, the critics are right. They are technically precise about stochastic variance and reliability failures. But here is the hard truth for your career. Those same flaws define where they actually work. The engineering shift isn't about replacing experts with perfect AI. It is about mastering inference arbitrage using cheap hardware for high-volume automation that humans cannot do alone, even if it fails 5% of the time. Let's start by validating exactly why you feel stuck. You see competitors shipping features while your team hesitates because the models are unreliable. This hesitation is not just caution, it is grounded in recent research from Northwestern University. A study there proved that an LLM can be perfectly calibrated yet fundamentally unstable. Even with a 90% accuracy benchmark, single-shot evaluations fail to capture reality. The model's stochastic nature means identical inputs produce wildly different outputs depending on temperature settings and internal randomness. This creates the reliability trap. You cannot measure success by raw accuracy scores alone because consistency matters more than isolated performance. A reliable system requires measuring internal stability, not just hitting a number once. If you try to force these models into roles requiring perfect precision, they will fail every time. This is why critics are right. LLMs do not work as autonomous experts capable of flawless execution on their own. The core reason lies in how these systems think. Current large language functions act like pseudo-System 1 systems. They operate with fast, intuitive pattern matching similar to human intuition, but they lack the System 2 deliberative reasoning required for complex planning or self-verification. This is a structural limitation of autoregressive models. They cannot perform principled logical entailment without external help. When you ask an LLM to plan a multi-step workflow and execute it autonomously, you are asking a pattern matcher to do logic work. It will hallucinate the steps because it never learned how to verify its own reasoning path against first principles. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This explains why autonomous agent planning is such a failure point in production environments. You cannot rely on an LLM to check its own math or legal constraints without introducing risk. The solution requires a fundamental architectural pivot known as the LLM modulo framework. In this design, the LLM acts only as a universal knowledge source or proposer. It suggests solutions rapidly based on patterns it has seen. Meanwhile, rigid symbolic verifiers and planners handle the actual logic, constraints, and verification steps. By wrapping the model in this layer of deterministic code, you create a system that is robust despite the underlying engine's flaws. The LLM proposes, the verifier validates. This allows your application to leverage the flexibility and speed of neural networks without exposing critical paths to hallucination risks. It turns an unreliable generator into a reliable component within a larger machine. But what about the cost? Critics argue these systems are too expensive to run at scale. Here is where we introduce the concept of inference arbitrage. The engineering challenge shifts from, how do I make this model perfect, to, where does imperfect automation create net value? You can use cheaper, smaller models for 95% of tasks because human review handles the remaining 5%. This creates a volume advantage that expensive, high-reasoning systems simply cannot match. Consider the critique bottleneck we faced early on. Initial attempts at using LLMs to critique other models failed due to vague feedback and poor correlation with actual errors. However, newer frameworks like DeepCritic have changed this landscape. By training smaller specialized models on high-quality, multi-perspective critiques generated by larger ones, we can create efficient deliberative critics that identify errors without the massive compute cost of running top-tier models for every single check. This allows you to automate quality control at a fraction of the price. The result is mass augmentation rather than replacement. You are no longer building systems where AI replaces human judgment entirely. Instead, you build pipelines where cheap hardware enables high-volume processing that would be impossible for humans to do manually. A developer can now handle 10 times their usual output by offloading the repetitive drafting and initial structuring to an imperfect LLM, then applying a verification layer before final delivery. This changes your career relevance significantly. You are no longer judged on whether you can build an LLM app that works once in isolation. The skill set is shifting towards system design for imperfect agents. Can you architect the boundaries where failure is acceptable? Can you integrate symbolic logic to catch errors before they reach the user? This is the new engineering mandate. Stop trying to force these models into roles requiring perfect autonomy. Start using them as high-speed, low-stakes automation layers wrapped in verification logic. Use inference arbitrage to justify running cheaper models for bulk tasks and only invoking expensive reasoning steps or human review when uncertainty spikes. The critics are right about the flaws, but they miss the opportunity that those flaws create, a new way to scale engineering work through mass augmentation at volume. The path forward is not perfectionism, it is architectural resilience. By accepting that LLMs are pseudo-System 1 thinkers without self-verification capabilities, you can build systems that leverage their speed while neutralizing their instability. This approach allows teams to ship features faster and cheaper than competitors who wait for perfect reliability or try to replace human judgment entirely. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.